Yes, Ashutosh. So that was a good interview actually. So how do you feel about the whole mock interviews and the guidance provided by Margdarshan?
Sir, since today I have requested you not to interview on HR side, only interview on technical side, and you have framed a very, very nice question that was relevant to NAPSU. And yes, with connecting with Margdarshan family, I think yes, it is very good platform for preparing for any PSU interview, apart from including HPCL or BARC.
Yeah,
Thank you, sir.
definitely, Ashutosh. Thank you very much for joining with us. Sure. Yeah. Okay. Hi, Vipasha. How are you? Hello. Are you mute or what?
Hello, is my voice audible?
Hi, your voice is coming, but not great actually. Yes, Hasim bhai. How are you?
I'm absolutely fine, sir.
Yes, that's good actually. So, can you please introduce yourself?
So myself, Hashim Ali Khan. I'm from Birsingur Pali, district to Maria, Madhya Pradesh. I've done my schooling from there itself, and then afterwards I've done my BTech from Indira Gandhi Government Engineering College, Sagar, Madhya Pradesh. And sir, we are a family of four. My father, who's an engineer, my mother, who's a proud housewife, and my younger brother. So, sir, my hobbies includes playing badminton. And sir, recently I've also developed a hobby which is I'm also very much indulged to nowadays in geopolitics.
Okay, that's nice actually. Okay, so this is your first interview by me. Did you give an interview earlier as well?
Yes, sir, it was, but not by you.
Okay, fine, great. So
This is my
how
second
do
interview.
yes? So how do you want this to be put as? I mean, should it be pure? I mean, technical HR or mix, or how do you want it to be?
Mix, sir.
Okay, great. So
However, you want it to be.
okay, fine. So Asim, why do you want join HPCL? Why do you want to join HPCL?
Sir, HPCL is a great company. With the integration of ONGC with it, ONGC acquiring 51% of the shares of HPCL. So now it is having a full hydrocarbon chain now, from exploration to the retail to direct to the customer. And sir, I also love the fact that how HPCL is covering the things, the new competition which is coming from the EV market. So HPCL is also catering that also very well. So I feel, sir, it's a great company to join.
That is great actually. So what are the products of HPCL?
Sir, petroleum. We have, sir, HPCL has petroleum refineries, the retail outlets for CNG, the LPG filling stations, LPG distributions, petroleum distributions, lube, lube manufacturing, lube distribution is also there. EV charging station has also been increased drastically from last 3 to 5 years. Uh, yes, sir.
That's correct. And do you know what's the LPG section of HPCL is called as?
LPG sections, I feel that HP gas it is.
Okay, fine, fine. Yes. So yeah, that is great actually. So can you tell me our strength and weaknesses, Hasim?
So my strength, I feel that it is that I am very calm in every situation.
Yeah, I can see that.
Uh,
That's really nice actually. Yes.
and sir, I also feel that I'm also very convincing to people. I'm very friendly, and I can talk to anyone I feel like.
That's really good. Really nice. So what are the subjects that you are comfortable at? You have command on, Hasim?
Sir, thermodynamics, FM, heat transfer, uh, these
Great.
subjects I'm
Yeah,
comfortable.
nice. So Hasim, what is surface tension?
Sir, surface tension. So there's a every molecule which is there attracts each other. We call it cohesion.
Mhm.
So, sir, there is on the surface, the each and every molecule within the water is attracting each other. And sir, within when we talk about the surface which is there, so sir, there's a unequal distribution of forces because from underneath the water is attracting, and from above the water layer there is air. So there is a not very good distribution of forces. So sir, it is a stretched membrane like which is formed on the surface, that is known as surface tension.
Correct. And can you give me an example of some application of surface tension?
So surface tension is used by mosques, mosquitoes,
Okay.
used to glide on the water by many
Mhm.
insects. Sir, we particularly we can make
Not
soap
exactly we,
bubbles.
but where we or in the industry uses surface tension.
So we used to increase the surface tension by adding detergent to it so that we could clean the clothes well.
So do we add detergent to increase the surface tension?
No, sir, to decrease the surface tension.
Why?
So because surface tension, there are small holes within the fabric. It's not totally closed. There are small holes in the fabric, and so where you can feel the dirt is being stuck. So while there's so sir, there's a surface of water which is formed due to the surface tension within these holes, and when we decrease the surface tension, so the layer which is formed cannot form, and the water can go through these things, cleaning the dirt very well.
So see, I mean, although your answer might be true, it's not that we want to reduce the surface tension, and that's why we are adding detergent. It could be a complementary thing, but essentially, detergent are little basic in nature, and the oils and dirt, these are acidic in nature. They are oily. So essentially, the detergent is added to attract those oil molecules. Surface tension is another
Okay.
application into that, but yes, I get your point. Any industrial application or something like that that you can think of?
I'm sorry, sir, I'm not able to recall it right now.
Okay, so in case of bearings, can you think now? What is a bearing?
So bearing is an device which is used to mount on a shaft so that we could have a rotatory motion.
Correct. Now, can you think of something related to surface tension there?
I'm sorry, sir.
Okay, so in the most simple kind of bearing, we have this shaft and we have a rod in between, and there is some oil layer that is formed,
Yes, sir.
right? Why do we have oil layer?
So that there we can avoid the surface to surface contact
Correct. And
between
that
the
oil
metal and
layer
metal
stays
contact.
there because of surface tension.
Yes, sir.
Okay, yeah. I mean, that's very
Yes,
niche
sir.
and very core application, but yes, that is the point. Okay, so how would you define or explain turbulent flow?
So the water moves in layers because there are so many molecules within the water. So whenever the speed is low, so the molecules are moving in a manner which are layer above the layer. And so when the speed is increased, then due to the drag, the molecules are not in a particular manner and go. There's a zigzag motion in the molecules of water. So that is water or any other fluid. So that is known as turbulence.
Correct. And does the turbulent flow consume more energy or less energy than a laminar one?
So it consumes more energy.
Correct. So turbulent flow must be bad, right?
Yes, sir.
So can you give me an example where
And so
we
in an
yes, yes, please continue.
so means when in case we want turbulence, then it is good. Such as for heat transfer, if you want to increase the heat transfer, then the turbulence is good for us. But say in the case we want to move something from one point to other, such as in the pipelines, then the turbulence is not good for us.
Energy wise, yes. Can you comment about flow rate in a turbulent flow?
Sorry, sir.
Energy wise, you are right. We need more pumping energy in for a turbulent flow. Can you comment
Yes, sir.
something about the flow rate of a turbulent flow?
Uh, sir, I feel that the flow rate is increased because the velocity of the flow is increased.
Okay, I mean, actually, that's not the exact answer. It's about the mixing that happens between the layers. So earlier it was ordered. Right now in turbulent flow, it's not ordered flow anymore. And because of the
Okay.
mixing increases and flow rate increases. But yes, your answer is correct. So can you give me some example where we desire to have a turbulent flow?
Sir, as in the case of heat transfer,
Example, any, if you can think of. I think he's out. Okay, you all can see me, I think.
hello,
Okay.
hello.
Yes, yes, continue.
I'm sorry, sir. There's a net
That's okay.
problem.
That's okay. Yes. So, any example that you can think of?
Yes, so the heat transfer, as I said, if we need more heat transfer, then the flow, if turbulent flow is there, then it would be very much beneficial for us because there would be more heat transfer because of the turbulent flow.
Correct. And any other thing other than heat transfer where we want to have turbulent flow?
So if there in case there's a fire and we
Mhm.
want the water to be means to set off the fire, then so we need turbulent flow from the pipe so that the water could spread everywhere and just put out the fire. I
Okay.
feel that way, sir.
Right, right. That's okay. So, sometimes for drag, actually, in case we want to increase the drag or something like that, we also need to have turbulent flow. Turbulent flow has a higher drag than laminar flow, obviously. So that is
Okay,
used
sir.
sometimes, in jet planes or something like that. When we want to stop the plane, for example, essentially what they do is they increase the angle of they decrease the angle of attack, so that increases the turbulency. But yeah, that's a correct answer. Uh, so, what are fins? Why are fins used in heat
So
transfer?
fins are used to increase the heat transfer from a surface, such as from the IC engines.
Correct. So we have fins, and what can we do to increase the heat transfer even more, maybe in IC engines?
So there are liquid cooled IC engines which are there. So because the heat transfer coefficient of air is very less and the water is more, so we can also use means having air being replaced by some other fluid, so that we could increase the heat transfer more.
That's correct, actually. So we do that. Yes. Mm, what is Newton law of cooling?
So Newton's law of cooling is HA delta T. So that means more time it would take for a surface to cool if the temperature difference is very low, and it would take less time when the temperature difference is very high.
No, that's right. And where do we use it?
So we use it in convection heat transfer.
Correct. And in case of heat exchangers, for example,
In case of heat exchangers, for what, sir?
do we take help of Newton's law of cooling anywhere? Can you think of that?
I'm sorry, sir. I think so. We use it when means the heat exchange is occurring between the two fluids. We use it that way, or when it is a shell and tube heat exchanger. In that case, we use it.
Yes, yes, you are in correct direction, actually, but definitely uh, that that happens. Okay, so here is a question for you. Okay, so let's say you are an engineer, you want to store a very, very cold surface, cold specimen. For example, you have liquid helium. Liquid helium forms at uh, around I'm not sure, maybe 30-40 Kelvin Celsius. Sorry, 30-40 Kelvin, degree Kelvin. It's
Yes, sir.
very cold, and the atmosphere is at 300 or something like that. Now you can imagine what will be the heat transfer gradient there. The
Yes,
temperature
sir.
difference is over 250 Kelvin here. So now you have been given that objective of creating a thermos. Okay,
Okay,
what does
sir.
a thermos do?
So it abstain something from leaving means it stops the heat from leaving out of that particular system which we have imagined.
Correct, correct. Heat coming in or leaving out, one and the same thing. So now, how would you create this thermos? You know, now you want it to be, totally isolated kind of thing from outside.
Yes, sir.
So how would you create it? Any design, that you can
Sir,
think of right now?
sir, I feel according to me, sir, what right now I feel is that we could make the two walls which are separating from each other by vacuum, sir.
Okay, and why
And so
vacuum?
holding them is, sir, because vacuum does not transfer any energy, sir.
Okay, so how does energy
The
in
vacuum
vacuum is
which can
transformed?
transfer
You're
through
right.
radiation, sir.
Through radiation, correct. So do you think there would be any radiation in between the vacuum that you are talking about?
So, so that also depends upon the emissivity of the surface which we are using.
Correct. So what will
So
you
the
do in
emissivity
this
also can
case?
be.
Correct.
So
Now you want
we
to
would choose
reduce
a
even the
material whose
radiation it transfer. How would you do that?
so we would choose a material whose emissivity is very low.
Correct. Emissivity and obviously emissivity and absorptivity are same. So yes, we can do that. So you need a black body or not black body.
Sort of we need a non-black body, sir.
Okay, great. Okay, Asim. So I wanted to ask you a little bit maybe on your hobby of geopolitics. Okay, so what do you think about oil prices currently in you know your geopolitical study point of view?
So I feel that the petroleum prices would be decreased, or if not decreased, the government would be benefited by the international oil prices, which are going to fall out for us, sir, for India, because Mr. Jay Shankar, our foreign minister, just had a trip to Iran, whereas we are not buying oil from Iran from recent 5 to 10 years because of the sanctions which are there, because America just put sanctions on Iran. But so we now have an agreement with Iran that we would consume the trade of oil with Iran, and sir, also the Venezuela oil which was there. So we are also going to take oil from Venezuela to our country so that we could benefit from that. And so also there's a recent studies also there that, I mean, not study, there's a recent news so that ONGC is also exploring oil near Andaman and Nicobar Island. So I
Right,
feel,
right.
sir, that in with respect to oil, India is doing a great job, and it's a good news for us.
Well, let's say, I mean, we are very oil hungry country, so let's see how does it plays in long term. Because that's not a very good thing to be at. We are extremely oil hungry, and oil is I mean, no country can live without oil. But yes, anyway. So
Yes, sir.
Hasim, let's conclude your interview. You had very good tell me about yourself. And as you said, your strength is to be calm. You actually showcased uh, your strength here directly. Okay. One suggestion that I would say is maybe you should do a little bit revision of mechanical topics,
Technical
okay?
subject. Yes, sir.
Technical more,
Yes, sir.
and prepare the HR side a little bit as well, okay? Like why HPCL and those kind of question. You had a very to
Okay,
the
sir.
point answer, and most importantly, you were even technical in that sense as well, okay? HPCL is doing this, it is coming in renewable, it is coming in EV charging and all. Those are really commendable things to hear from someone. But just understand that whenever you are saying something like that, it could bring in more questions as well.
Okay,
Okay,
sir.
not very deep, but something like, who are we partnering for the EV charging infrastructure with, and do you think EVs are sustainable, something like that. Nothing very serious, but still, if you are अगर हम कुछ बोल रहे हैं एक्स्ट्रा, तो फिर उसके ऊपर कुछ ना कुछ क्वेश्चंस आ सकते हैं. So just be
Okay, sir.
you passed out in 22, right?
21, sir.
21. Okay. So this question could come up कि मैंने actually ये पूछा नहीं. I don't know. I think I missed that. So what are you doing since 21? I mean,
I'm preparing for the exam, sir.
okay, great. So
And so initially I started means I whenever I dropped out from college, that not dropped out, so I passed out from college. So then afterwards I started computer science, sir. I
okay,
went into web development.
okay. So
And
you
then
don't
after web
you're
development, I
telling
feel
me
that
this. That's okay. Don't tell it there. Okay.
I should not tell these things
No,
in
don't
front of them.
tell these things. Okay. Don't divert the topic overall, I would say.
No, sir, I was exploring the things, but I feel that things don't work out for me. So I ended up in getting
That's
engineering, that
okay.
I will
And
do
just
this.
say that you are totally determined to, get a job where you will be able to serve the people. Okay. Say this point. That way you can definitely
Yes, sir.
justify your 3-year gap. Okay.
Yes, sir.
Yeah. Anyway, chalo. So let's conclude your session. So just Hasim, give me a little review of how did you find this interview as overall. You had been to 2 interviews so far. Both HR and technical was covered. So how do you find it? Any improvement from our side, or anything that you would like to say?
Yes, sir. Shall I start?
Yes, please.
The interview went very smooth. I felt that I also improved a bit, but from both the sides, got this. Uh, I've got this thing that my technical should be brushed up a little bit. And I also feel the diversification of the teachers, that we got a different teacher initially when it was my first interview, and for the second interview I got a different teacher. So that is also very good, that a single teacher is not getting your interviews, because there would be a panel of, I feel like, 5 to 10 people. So that would be taking your interview. So different type of questions would be there. So I feel diversification of teacher is also very important.
Okay. Thank you, Asim. That's totally true, actually. We try to make it as diverse and as diversified as we can, so that everyone could get some kind of sense out of it. Okay, so let's conclude your session. I'll move on to the next one now. Bipasha, you want to join in?
Yes, sir. Yes, sir. Am I audible now?
Yes, you are audible now. Yes,
Okay.
good, great. Sure. I think we'll have to join again for the meeting, but we'll do that. Okay, don't worry.
Okay.
Yes, wait, let me just. Yes, Bipasha. Can you please introduce yourself?
Yes, sir. Good afternoon, sir. My name is P. Bipasha Baxter Kotri. I belong to Sagar, Madhya Pradesh, and I have completed my schooling from Sagar itself. I completed my bachelor's in mechanical engineering from IIT Devi Vishwavidyalaya, Indore, in 2022, and scored a GPA of 8.43. I'm a fast learner, highly motivated, and enthusiastic about contributing to Hpcl.
Great.
That's it, sir.
So that's actually a very good introduction. I mean, you are definitely improved since the last time we met. So Bipasha, why do you want to join HPCL?
Sir, I think HPCL, first of all, is a Maharatna, and it holds a prominent position in oil and gas industry. And its commitment to excellence for in all aspects of its operation uh, aligns with my own values and career aspirations.
So what are your values and career aspiration?
So I want to improvise continuously. I want to increase my knowledge and want to contribute to real world problems and providing solutions, efficient solutions to real world problems.
That's good. So can you tell me one thing where HPCL is providing good solutions to people or to world?
So, sorry, sir, I don't know. Sorry, sir, I'm not prepared. I'm a little stuck here right now.
That's okay. In that case, you have to think it on the time and then tell. Okay, even I don't know the answer to this
Okay.
question. Okay. But you
Yes,
were
sir.
in earlier interview and he was talking about EV infrastructure. So you can say, oh, you know what, electric vehicle has a problem of charging actually, and HPCL
Yes,
petrol
sir.
pumps are available everywhere. So HPCL is, going ahead in that direction, so that it could provide
And plus,
EV charging.
yeah, it's providing zero products. Also, I read about it on HPCL's website.
What
Some of the
products?
products. I remember one was HPCL Furno Care that was related to fouling in boilers and shells. So then
Correct.
there's a deposition of low conductivity. So that's a complete oil cleaning package, online cleaning package. So that's a problem to a solution.
I
That's
say
a solution to a problem.
you only know the answer. Even I didn't know this thing. Okay. So now
Actually, I'm a little.
Yeah.
I know the answers, but I'm unable to answer right now.
हाँ,
Sorry,
ये
sir.
तो मुझे पता भी नहीं था ये क्या क्लीनिंग विनिंग का फाउलिंग का करता है HPCL करके, बट या गुड वन एक्चुअली. हाँ, yes Vipasha. So can you tell me your strength and weaknesses?
So my strength is that I am a very, very strong believer of hard work. I believe that smart work can,
Okay, you
smart work
need to look
can,
up. Yes,
okay, sir,
now.
sorry.
हाँ.
Smart work can betray, but hard work never betrays. So I'm a very strong believer of hard work, and I'm always enthusiastic towards learning and progressing. I have this progressive mindset and improvising things. My weakness would be I'm not at multitasking. I like to divide things. I want to finish that task first, then I would go to another task. So I'm not a multitasker.
Great.
That's my weakness.
And can you give me some example where you experience that hard work is that you believe in hard work and your belief is true actually?
So during my gate journey and during my after I completed my engineering, after that I've been preparing for gate and other PSU exams. So I've been continuously working hard for that.
Yes, that's actually no. You should say, you are working hard, but it resulted into something. Okay, I ask you, where did you experience this? You need to hear the question
Okay,
properly, maybe.
okay, sir.
Okay, that's all right. So today I can't give mock interview. हाँ ठीक है चलेगा, इवनिंग में कर ले लेंगे, not a big deal. Fine. Okay, आपसे नहीं, I was talking to Prathamesh. Okay, yes. So Vipasha, what is Breton cycle?
Breton cycle consists, sir, it's energy producing, work producing cycle, and it consists of two isobars and two isentropics.
Great. And as we know, not all the time, I mean, every time, the second law says that the process will not be isoentropic, right?
Yes, sir.
Yeah. So what will happen due to that non-isoentropic process or not so ideal isoentropic process in a Breton cycle?
In our Breton. So when the expansion process is taking place in the Breton cycle, the work input will get somewhat increased due to not so ideal process of isentropic. And when the compression process will take place, sorry. Can I start again?
Correct.
In the expand process, while in a Breton cycle, when we'll get the work output, the output will a little bit decrease because of not so ideal process. And when in a compression process, the work input which we have to provide will increase somewhat.
Yes. So essentially, due to the friction and all these irreversibilities,
Due to
yes,
irreversibilities.
we are losing out on the efficiency actually. So that's what happened. Uh, Great. So what is Poisson's ratio?
Poisson's ratio is the ratio of lateral strain to longitudinal strain.
Correct. And where do we, need to use it or something like that?
When a material is stressed when a material is stressed, then that the Poisson's ratio is used to find out what impact the stress in a particular direction is having on the other direction, mutually perpendicular direction.
Correct. And usually in real life scenarios, it is not that apparent, but when the load increases, then definitely. Now, what is ductility? How would you define ductility?
It's related to tensile strength. It's about how much a material can be drawn to wires, how much it is able to be drawn into wires.
Okay, so this is the definition as per class 6th. Okay. Now I want you to define it as per a BTech graduate.
Ductility. Ductility can be.
When do you say a material is more ductile than the other one?
When it resists deformation, when it's subjected to tensile strength. When it when it shows deformation, but it does not show fracture when it's subjected to tensile strength.
It shows deformation, but no fracture.
But it, yes, sir.
Correct. So it
No
is like
fracture,
an,
that's what I.
yes, now that is a ductile material. So now that's a that's a BTech graduate definition. Okay. And how would you define a
Okay.
brittle material?
That so it does not show any deformation. It fractures when it's subjected to tensile.
Correct. So what is the correct name of that deformation that you are talking about? You know, that the ductile material shows, but a brittle material doesn't.
Yes.
It has a name.
Elastic deformation.
No, it's not
Elastic
elastic deformation. Elastic deformation means the deformation that will come back to its original place. Okay, can you draw a stress strain curve diagram for a ductile material?
Okay. Correct, sir.
Okay, just a minute. Yes, correct. I saw it. Yeah. So, and can you explain me the different zones that you draw?
That's one. So till A, it follows Hooke's law,
Correct.
and it's elastic. Till
Right.
B also it follows Hooke's law, but it stops showing elastic behavior.
Okay.
Then from B to C, it's
Mhm.
showing strain hardening.
Correct.
And C is the ultimate stress, maximum stress which the specimen can hold.
Mhm.
And at F, it shows fracture.
Correct. So what kind of deformation that strain hardening is called as? One is elastic deformation. What is another type of deformation?
Plastic deformation.
Yes. So essentially the ductile material
But
has a very ductile
it also
material,
shows grain growth also.
not growth
I
actually.
don't
It's,
remember.
even
It
I
was something
forgot it. I
related
think
to
yes, yes, a grain displacement. If I am right, it is grain displacement. But yes,
grain boundary displacement.
correct. Grain boundary displacement. Yes. Yeah, we study that in material science actually. Yes.
Yes.
Great. So you know, we have keys in the we use keys for house locks and all those things. How are those keys manufactured? What's the process
Sorry,
that we
sir.
use to what
Sorry,
is the
sir.
process? Okay, do you have pen? How was the pen casing was manufactured?
Pen casing by extrusion.
It was not by
Extrusion,
extrusion.
not it's
I don't think it's by extrusion. See, extrusion needs to have a very constant cross section. Okay.
yes, sir.
Yes. So can you think of how was it manufactured?
Sorry, sir, I cannot recall right now.
Okay, I'll make the question even easy. We have water bottles, right? The plastic
Yes, sir.
water bottles. How are the plastic water bottle
Yes, sir.
manufactured?
I'm unable to recall right now, sir.
Okay, that's okay. So okay, so
So
the
please tell me.
yes, I'll tell. Meeting will end. Join back and we'll discuss it. Okay.